This video is brought to you by azamsharp.school, which is one of the biggest producers of iOS development videos. I mean, just check out this. 16 courses, more than 90 hours of videos, more than 90 hours of content, and it just keeps on increasing. So by the time you're watching these, it might be like 20 courses with 120 hours, all right? And now on Azam Sharp School, I do offer the annual membership, which is $249, and monthly membership, $25 a month. And what's great about these membership options is that once you sign up for these membership, you can access to all 16 courses. And check out these amazing courses: test-driven development in iOS, reactive programming combined, Swift Vapor, server-driven UI, Reality Kit, Swift Data Bootcamp. I mean, it just contains all the things that you need to become an amazing iOS developer. And I keep on adding more courses. So there are more courses that will be added later on. So this is an amazing deal. You can check out the testimonials from our existing students. And this is again one of the largest catalog for iOS development courses. So sign up for either a monthly membership or annual membership and enjoy all of these courses. Thank you so much. Let's go ahead and get back to the video. In this module, you'll be learning about how to create concurrent tasks. You will learn how to create concurrent tasks using many different techniques, including async let syntax and also task group. The async let, which is actually spelled with a lowercase async let, allows you to create a task, and that task can have number of child tasks. Those tasks, the child tasks, will be created using the async let syntax. In other words, the child tasks are basically just variables with async let syntax, and that will allow these tasks to run concurrently. On the other hand, if you do have dynamic data and you don't really know how many concurrent tasks you want to run, then maybe a task group is a much better choice. You can run different groups within a task, and then each group can run itself a child task. The great thing about the child task is that you are free to use async let syntax for the child task, while the group is using a task group syntax. So in this case, you can have multiple groups, and each group can run multiple child tasks concurrently. Let's go ahead and take a look at what we will be building. We'll be building a random images and random codes application. This means that we will be communicating with an image API as well as the random code API. We will check out the implementation using first async let syntax, and then we will upgrade it to start using task groups. Let's go ahead and get started. All right, everyone. Let's go ahead and put our knowledge to test by creating a simple application that will download random image and a random code from two different sources. I've already created a Swift UI project. Let's go ahead and add a new folder or a group for services. Since we will be using an MVVM design pattern, I'm also going to add model folder as well as the view model folder. Perfect. Now I can go to my services and add a brand new file for my web service. This web service will be responsible for getting the data for a random image as well as a random code. We will begin with creating a class called web service. Great. The web service class will have a couple of different functions. One of the functions would be to get random images. So get random images. We are going to pass in the ID an array of IDs. This function will be async, and it can throw an exception, and it is going to return you an array of random image. That random image will also have a random code attached to it. Now we don't really have anything called random image. That is our model. So let's go ahead and create a new model, and we're going to call it random image. The random image model will be pretty straightforward. We will have two different things in the random image model. As you can see over here, we have the image and we have the quote, which is of type quote, which contain one property called content. Now getting back to our getRandomImages function, since we have IDs, we can go ahead and loop through it for ID in IDs. And we can call another function, which is simply getRandomImage, passing in the ID that we just have. There we go. Having trouble typing. And we will get a random image. Now, we don't really have this function called random image, so let's at least create some sort of a signature for our getRandomImage function. GetRandomImage function is also an async function, so when we call getRandomImage, we will have to await for it. Great. Once we have the random image, we will put that into an array. So let's go ahead and create an array in getRandomImages. Once we have the random image, we can get it and we can append it. Random image. The getRandomImage is a throws function, so this means that it can actually throw an error. So we have to make sure we're calling it with try await. The next thing we need to do is inside this particular function, getRandomImage, and obviously make sure that you are returning the random images. Great. So now getRandomImages does return you an array of random images once it has been received. We still have to implement getRandomImage, whose responsibility is to go and get a single random image. Now, before we do that, we have to look at different websites. Where are we getting the random image? And also, where are we getting the quotes? So let's go ahead and take a look at both of those sources. In order to get the random image, we will be using an online service called Lorem Ipsum. And you can see that they have different URLs, and this particular URL can give you a random image. We will invoke this URL. We will also pass something extra to it so that we are not returning or getting the cached copy. So we will simply invoke it with some sort of a UUID string. If you want to get a particular image or a specific image, you can use different things. For our quote, we will be using a GitHub repository from Luke Pive. It's called Quotable, and we can also go and check that in the browser. This is going to be the response that we're getting. So now we have two basic APIs, one for image and one for quote. Let's go ahead and try to implement it so that we can download the images. The first thing we need in order to download an image is the URL. I'm going to go ahead and create a new group, and I will call it utils for utility. Inside the utility, I'm going to go ahead and add a new file for constants. Now these constants are going to describe different kind of constants that we need in the overall app architecture. So I'm going to go ahead and create a constants, and now I can say struct URLs. The first URL that we want to create is using the static function, and we will say get random image URL. This URL is not really going to get anything. I mean, we are returning a random image, so we are not really going to pass anything to it. However, if we simply go and copy the URL that they're saying, we're not going to be able to get a random image because that particular request will be cached. So if we go and return a new URL string, and I will simply go ahead and do something like this, then there's a very good possibility that I will simply get a cached image, which might be cached on Apache or some other server. They might be using a CDN or something. So in order for this to work, I have to make sure that I'm changing the URL a little bit. This means that I can simply go ahead and pass in something that will change every single time. And that something can be a UUID, .UUID string. So now I will always be sure that the URL, when it is invoked, it will always have something unique at the end. The other URL that we need is the random quote URL. So I'm going to go ahead and invoke it or expose it like a normal property. Now let's go to the getRandomImage again. Inside the getRandomImage, I will first go ahead and get the URL or the actual URL for the random image URL. Next up, I will go ahead and get the quote URL. You can see that we don't really have anything called network error being defined. That's not a big deal. We can define this error somewhere on the top. That will indicate that this kind of error can be thrown. Next, we will go ahead and you can see the random image URL that doesn't really have anything. So let's go ahead and copy this, get random image URL. There we go. It doesn't really take any parameters. Now we can use URL session.shared.data, and we can use the data, the one that takes in the URL. We will pass in the image URL. We don't really need the delegation part. This is going to return us data, or we can even say image data, and some sort of a response that we are kind of ignoring. Since this is an async implementation, we have to implement or call it using try-await. We will do the same exact thing, but for the random quote data. So let's go ahead and name this random quote data. And the URL will also be the random quote URL. Great. After that, we are going to get a decoder, and we will decode the quote, and also we will get the data. But before we go much further, what do you think is going to happen right over here? When you see await, what's going to happen is that this particular task will be suspended until and unless we download this particular URL, which is the image URL. Once this is resumed and it has taken out of suspension, then we will again wait and get the random quote data. We can run these two tasks concurrently so that they don't really have to suspend at this time. We can use async, which we have learned earlier on. Async let as a variable, and we can also use async let over here. This means that both of these tasks are going to function concurrently at the same time. Next, we can go ahead and decode the quote. This is going to be using the JSON decoder. If there is any error, then JSON decoder can fire an error. The important point to note over here is that our usage of try await random code data. Remember that on this particular line, which is 41, the task or the concurrent task will be immediately begin. Same with the image data. It's not going to suspend the particular thread. It's just going to start the concurrent task immediately. But when it reaches this point, when they have to evaluate the task and get the actual random code data, this is where the suspension happens. Once it has suspended and we got the code, then we can go ahead and finally return our random image. You can see that in the random image, we have to pass in the image as well as a code. We still have to perform a try await on the image data because that is not been evaluated. And whenever we do a try await, again, our application or our thread, that particular thread will be suspended and it can do some other work. When it is available, the image data is available, then we can resume it. Now we can go ahead and pass code also. Great. And now we have created our getRandomImages function as well as the getRandom function. We have also used the async let syntax to start two concurrent threads immediately. This means the image data will be fetched immediately as well as random code data. They're not going to wait for each other to finish. They will start fetching the data. The wait will start when they are awaiting for that particular task to complete. Once that task is completed, which is random code data, might be a good idea to think that the image data will also be close to be done because both of them are working concurrently. So once we reach line number 47, it is quite okay to assume, depending on the scenario, that the image will also be downloaded. Hence, these two tasks are working concurrently. Now, this is great. We have created our web service. We have created our random image model. But if we want to display something on the user interface, we have to use view models. Let's go ahead and in the next lecture, take a look at how view models can call the web service and get the data. Now let's go ahead and implement our view models. Inside the view model folder, I'm going to go ahead and add a new file. And this file, I will call it random image list view model. The random image list view model is the actual container model that controls everything that happens on the random image list screen, which in our case is a content view. Each of the random image as well as a code will be represented by a separate view model. Let's go ahead and create a class, and we will go ahead and call it random image list view model. This is going to be an observable object. I will also mark this with main actor, and don't worry, we will read about actor, we will learn about actor a little bit later on, but main actor is basically saying that all the properties and the functions inside the random image list view model will be happening on the main thread, hence the main actor. Next, we're going to go ahead and create get random images function where you can pass in IDs. IDs don't really specify the IDs. These are just a number that we're passing so that we know that we're asking for 5 images or 10 images or 100 images. This particular function will be an async function. So we have marked this with async. Now we already have the web service. So we can go ahead and call web service dot get random images. We already have the IDs, so we can simply call the web service with the IDs. But the web service itself is an async function, so we can use await, and the web service can throw an exception, so we will use try also. Since we're using try, it might be a good idea to start using do, and then also catch any exception that happens within the web service and print it out for now. The web service itself is going to return you random images, which is of type random image. It's basically an array of random images. These are the model objects. We can't really send them back to the UI because their structure might be very different of what the UI is expecting. For that, we're going to go ahead and create a random image view model. The random image view model specifies a single random image plus the code that will be displayed on the screen. You can see that we are using identifiable protocol so that it can easily be displayed in a list of items. We're also using the image and random image property to get the actual UI image. In order to use UI image, we will have to import UIKit. Great. We also have a code property, which is reading from randomimage.code.content. If you go to the random image, you will find out that the image property is simply a data. You can call it data if you want to, that's perfectly fine too, but we are just calling it image. Once we pass in the data, which is the image, we will get the image of type UI image. Now, inside the random image list view model, we can go ahead and create an array of view models. This array will be of type random image view model. Now we need a way to convert our random images, which is of type random image, to random image view models array. We can simply use a simple map function to do that. One of the things to note over here is that the random images is a published property, and published properties are supposed to be set on the main thread. That's the main reason that we are using the main actor. The main actor is saying that all the different properties and the functions inside the random image list view model will be run on the main thread. This means that we don't really have to wrap this into a dispatch main async because we already know that the random images property will be set automatically on the main thread. That's one of the benefits you're going to receive from the property wrapper main actor. So now we have implemented our view models. The next thing that we need to go is to implement and display the random images as well as codes on the screen. Now let's go ahead and move to displaying the images on the screen. So we're going to go to jump into the content view. And the first thing we're going to do inside the content view is going to create an instance of random image list view model. So let's go and do that. There we go. Now we have the access to random image list view model. We want to make sure that we are displaying the list, but apart from displaying the list, we also want to make sure that we are calling the get random images. So I'm going to go ahead and create a list, and the list is going to run through the random image list view model.random images. We don't really have to provide an ID for it because the random images are of type random image view model, which is already conforming to the identifiable protocol, which you can see right here. We will get access to a random image. We will specify random image. Now you can use any method to display the random image. I'm simply going to use an H stack with an image as well as the text. The one thing to note over here is that the random image.image, which is going to give you the UI image, we're performing a map on it. The map function is going to give us the unwrapped version of the UI image, which we are passing it to our image view, because one of the overloads of the image view does allow you to pass a UI image, and then we finally resize it and set the aspect ratio. The code is pretty simple to display because we're simply displaying the actual code, and that's it. Let's go ahead and build our application. The other thing that we need to do is to make sure that we are calling the actual getRandomImages function. So let's go ahead and call this. We can call it right inside the task because task closure is already marked with async. So we can await inside the task closure. Perfect. Now let's go ahead and run the app and see that if we can display the random images. I'm going to launch the app on an actual simulator. So you can see that my iPhone 12 Pro Max simulator running iOS 15 is the one that we're launching. Depending on your network connection, it can take a little bit of time to fetch the images as well as the random codes. But that will be hopefully for first time. On the next time or the subsequent time after that, it will be much faster because it does have to go and warm up the actual services. And once we have the services warmed up, then we will be able to fetch the images as well as the codes. And there you have it. We have been successfully able to load random images along with the random codes, which are coming from two different places. The random images is coming from a different API and the codes are coming from a different API. Now this is all great, but we also learned earlier about task groups that can allow us to create dynamic number of concurrent tasks. So let's go ahead and update our application to use task groups. In the last few lectures, we implemented our random image and random code application, and we were using the async let feature to create concurrent tasks. But what if we want to run many different tasks concurrently? In that case, we have already learned that we can use the task group. So let's go ahead and see that how we can utilize task groups in our random code and images application. Right inside the getRandomImages, we are performing a loop. Every time the loop performs or runs, we await for the result from the getRandomImage. Once we invoke getRandomImage, it creates two different child tasks that are run concurrently. But the actual output or the result must be awaited, as you can see right here. So the loop is not going to move forward unless and until we get a result from getRandomImage. We should be able to run more tasks concurrently by creating a group. This means we can go ahead and wrap everything around with throwing task group function. So we will await and we will say with throwing task group. In this case, when we are just starting out, we will put the child task to be void, meaning that our child task or our group is not really going to return anything. We will change that in the future when we see the need to return something. Now we can go ahead and put all of this code for the loop inside our task group. If we want to perform more concurrent tasks, we can use group.async function. So we'll call group.async, and we can put our code that we can await for inside the async closure. This means that it's going to run the loop, going to create one single concurrent task as a group, and that group will have two more concurrent tasks which are coming from the getRandomImage, represented by async let. One of the problems you can see over here is our random images is created outside. And this will, since this all code is running concurrently, this can become a concurrency issue or a data race issue. Who is going to come back first? Just because we're passing an ID 1, 2, 3, it doesn't really mean that the ID with 1, 2, or 3 is going to come back in sequence. And if it's not coming back in sequence, it can possibly overwrite other things. So instead of doing this part or adding or appending it to random images, we can go ahead and return the ID, and we can go ahead and get the actual random image by calling getRandomImage with the ID, which is the same thing we have done on line number 27, so we don't really need that over there. If you look at what the task group is supposed to return, you will find out that it's returning void and nothing much. We will have to go over here and update this so that we are returning a tuple with the first item as an ID, and the second item will be a random image. Great. Now if we go ahead and build our application, you can see that it is still saying that we need a closure because we are trying to call getRandomImage inside it. So let's go ahead and add self to it so that we are creating a weak, well, we're creating a reference to our self over here. Next, once this loop actually finishes and all of these group requests have been created, we can use the async sequence in our code to process the result one by one. And as we learned earlier on, we can use async sequence by simply using for await or for try await, awaiting for a tuple, which will be an ID, which we don't really care about, and a random image. Since this is an async sequence, all of the sequence is processed in that particular order. And since this is processed in that order, what we want to do is we can simply go ahead and append it to our random images. There we go. And now we have successfully added task group features to our getRandomImages function, which will allow it to run more tasks concurrently. For each of the ID is going to create a task or a group task, and from within each group task it will create two child tasks which are based on the async let feature. Now if we go ahead and run our application, you can see that it's going to create groups, and each group will have multiple concurrent tasks using async let. And now we can also see the random images as well as the random codes. So this is just another way of doing the same thing, but in this case we have created more concurrent tasks by using groups. Now, one of the things that you may have noticed is that even though we are running our groups, and inside each group we are running two concurrent tasks, it doesn't really matter how many groups we create. And it doesn't really matter how many child tasks we create, because in the end, your view model does have to wait for all the images. So if I go ahead and run the application right now, you will see that I don't really see anything on the screen. I will have to wait for all the concurrent tasks to finish, and then eventually, when all the concurrent tasks have been resumed from suspension, then eventually I see all the images. What if we can show the images as soon as they are downloaded? So let's go ahead and implement that particular scenario. For this to work, the first thing we are going to do is jump into our web service, and you will make sure that your getRandomImage is not a private function. It's a public function, or it can be accessible from outside. And the reason is that we will be using this function and calling getRandomImage function from our randomImageList view model. So let's go ahead and do that. Instead of doing and waiting for all the images as we are doing over here, we're going to get call from getRandomImage. We will get the image and we will display the image on the screen as we download. And you will see the difference will be really clear. So right over here, I'm going to go ahead and start with my try await with throwing group. This is the same exact code that we have typed earlier on. So our group is going to return us the tuple, which will consist of an int and a random image object. For our body, we will get the group. And now we can do some sort of a task inside our group. I'm going to go ahead and run a loop in IDs. For each ID, we are going to call group.async to create a particular task. From over here, we can go ahead and call our web service. Now we are inside the loop. I don't want to create an instance of the web service again and again. So I'm just going to go ahead and create one single instance for web service. There we go. And from inside over here, we can call web service dot get random image with the ID. The getRandomImage is an async function, so we have to await for it, and it can throw an exception, so we can go ahead and call it with a try. This is going to return us something, but we want to make sure that once we get the data, we don't really modify anything, and we can't really modify anything. If you try to modify random images, which is declared as a published property, and if you try to modify it inside the group.async, it's not going to work because you are in an async context, and by changing the random images array, you are trying to create those race conditions. So instead of that, we are going to go ahead and return a tuple, which will consist of an ID and the actual task that we are awaiting. Let's go ahead and build this. Great. Once this loop is processed, meaning it has started those concurrent tasks, which in turn will start two more child tasks, which are inside getRandomImage, now we can await for their return. We can use the for try await. This is an async sequence. We're going to get an ID, which we don't really care about, so we can say ignore it. And we will say get in random image. This will be a random image data type in a group. And now inside over here, we can go ahead and access our random images. So our random images is of type random image view model. We can go ahead and append. The random image itself is a random image model. So we only can go ahead and add a random image view model and pass in the random image. Great. And that is pretty much it. Every time you are going to perform a request and it is processing that request, we are going to get a random image, and then we are going to go ahead and add it to our publish property, which is random images, which in turn is, since it's marked with publish, it is going to tell the view that, hey, you should refresh yourself because some new item has arrived. And the view should go and it will update itself. Keeping that in mind, let's go ahead and run our application again. And we will see that it's much, much faster. You can see that all the images, as they were downloaded, they were also given to us. Instead of waiting for seconds and seconds for all the images to download, we are doing a progressive download as well as display. Let's go ahead and run it again. There we go. You can see that the images are downloaded very, very quickly and sequentially. Which image comes first, we cannot really tell because these are asynchronous tasks. Whichever comes first, we just display it with a particular code. Now, if you want to show this side or see this side by side, that how much time it will take if you are waiting for those concurrent tasks to complete versus this particular approach in which you are actually downloading and displaying at the same time as you get the data, let's go ahead and take a look at a sample video. Here is a small video that I have created. On the left side, you will be able to see the application which is waiting for all the concurrent tasks to complete. And on the right side is our current code, which is running, downloading the images and the codes and displaying as it downloads. Let's go ahead and see how it works. You can see on the right-hand side, it was very fast and it's able to download all the images and the codes one by one. And it took the left-hand side a long time because when all the images and codes were downloaded, then and only then the interface was refreshed. So you can definitely see the difference between the two different approaches that we have taken. So hopefully that will clarify a lot of different things and it will give you ideas of when it is time to progressively update your interface as you're downloading the actual images, codes, and data. In the last lecture, we added a feature of progressive downloads, which means that the images are shown as they are downloaded. Great. Now, what if we want to perform an unstructured task? This means that when we click on the refresh button, we want to download images again, perhaps new images. So how can we accomplish that? If you open your content view, you can see that currently the action button is not really doing anything. So what we want to do is we want to perform get random images again. And we are already doing get random images. So this means we can simply copy it right here. If I go ahead and try to build my application, it is going to give me an error. And the error is basically saying that you're not really in an async function to use the await feature. If I try to call my get random images without the await feature, then again it's going to complain that the get random images function, which is part of the random image list view model, is an async function and you cannot call it without awaiting for it because that particular task will be suspended and then return immediately, and then it will be resumed once we get the images. So we have to use await. But in order to do await, we have to have async. Since we are inside a button, click, button, tap action, we cannot really decorate that particular event with async, but we can use the async closure, which is known as the task closure. So by wrapping our await code or async code with the task closure, we can perform this unstructured task. Now let's go ahead and run the application again, and you can see that it's not really going to give you any error. First, it will load everything because that is loaded when the page actually loads for the first time. And now if I go ahead and click on these images, you can see that it's still printing out the same exact images. it's not really doing much, even if I go ahead and click multiple times. The list, however, it might be getting much longer. So let's say that the last one is the cloud. If I perform the list, you can see that it is appending at the bottom. Maybe we don't really want to do that. We want to make sure that when we call getRandomImages, we want to clear them out and perhaps perform the random images thing again from scratch. Let's go ahead and jump into getRandomImages. You can see that when we call getRandomImages, we create an instance of the web service. We still have a copy of the images which were previously loaded in the random images array. We should be able to simply go ahead and initialize the array again. This means that every single time we are performing getRandomImages, it's going to not add it to the previous collection, but it is going to perform those 100 images again. And instead of appending it at the bottom, it will clear out the list and display us the latest one. And now you can see that it is working perfectly fine. And there you go. We are able to create a random code images and random images app. We are also able to perform the unstructured tasks as well as the structured tasks that we performed over in our web service using the grouping of the tasks. And we also were able to progressively download the images and then display it on the screen. So that's a lot of work that we have done in this app. Make sure that you download the code associated with the application, which is added as a resource file. Thank you.